I developed this one with a Calc 1 vision in mind, which I'll probably teach in the fall, which is similar things that we would teach in Calc 1, but then you can see there's like a little bit extra at the end to try to push students into thinking a little bit more deeply about analysis and interpretation. So this was an idea. So this is probably when I use it, I'll pick a better graph, but this was like last week. So this is solar panels for my house last week, and the energy coming out. So this is the power. So this is kilowatts, and then the energy would be basically the area under the curve, right? So we're trying to get them to understand that this is a plot of rate, and they want to compute the total energy by approximating the area under the curve using rectangles in our Riemann sum. So this is often what we would do in Calc 1 is give them a graph which has no meaning behind it. It's a graph, and let's compute the area under this graph. And so this is an idea to try to put some meaning behind it and then have the students make some inferences, basically. Okay, Rose, so you go to the, so stop me if, I don't want to go too much into detail, like the exact problem, but I can, of course, talk more. So here I tried to think about problems that would address each component somewhat separately. So the first one is just sort of reading off from the graph, estimate the maximum and at what time did it occur. So this idea would hit pretty directly convert. So taking relative quantities and convert them from a graph to numbers or to words. So in general, I thought that this big structure of like graph, do some computations, do some analysis is a nice framework for hitting a lot of the SLOs that you could take into almost any course, right? So then here, the next one, you'd want them to do some sort of computation. So here, assuming that max power was generated for 10 hours, what would be the total energy for the day? So here, this use is one where mostly our students like, that they can do, right? Take some numbers, multiply them together, take the derivative. This one is usually scores pretty well. So almost all, for me, like in a math course, like you'll always have one of those. It's the other ones that are a little bit harder. The second one, which is asking them to explain how the total energy is related to the graph. And so I want them to say the area under the graph is the total energy. This one, I need them to do it. I'm not super sure what SLO would work, but maybe communicate, because it's not in connection with an argument, but I guess it's connection with the purpose of the work. So this is something that I need on that sheet for them to do, although maybe the exact alignment for the SLO isn't super clear. But I think that would happen in most assignments anyway. Yeah, interpret. Totally. Yeah, great point. Interpret would be, but I think that interpret is not in the SLOs. So interpret has been connected with communicate. So if we look at the interpret is in the AACU, totally. But if we look at the FQ that we've developed, interpret has been kind of connected with communicate, I believe. But I definitely think interpret is what we're trying to get out there. Yeah, thank you. And I will also say this is not just my idea. I think this is a very common calculus example to do a Riemann sum with power generation. Yeah. So it's definitely there. But so when we get at the end, these are the kind of the harder ones to pull at the students. So one is this idea of select. A lot of times we say like take the derivative or, use the slope to find the tangent line, things like this. So trying to get a question where they have some choice. This one kind of, they have a choice of either using left endpoint, right endpoint, or maybe they could use a max or min over the interval, and whether your estimate is over or under the true value. So thinking if I'm using I might play around with this because usually we use left and right, but here with kind of a symmetric left and right doesn't necessarily get at over or under. So I might cue this a little bit differently and ask them to pick endpoints that would force an underestimate or force an overestimate. But yeah, hopefully throughout the course of this learning community, I will refine this idea. But the idea of selecting and also having an understanding about limitations, this is definitely something that wouldn't traditionally be in like a calculus course. And so this is one of the areas where when it was scored originally, it was really lacking because you just would never ask the students to do it. And so the final one is this communication and evaluation. So, you know, is there enough energy to run my house? Do I feel confident in my estimate? You know, I think there is, but maybe there isn't. Maybe the error is, you know, maybe I did an overestimate, so I might not be super confident. And one thing that I noticed when I was doing grading is the artifacts that did the best or that were easiest to grade well were ones where you were requiring full sentences, which again, not something that's always required on a calculus assignment. But I found that like asking them to say like use 2, 3 full sentences, using quantitative data to support your conclusion, that kind of leads them to a better expression of the knowledge that they have and that we're trying to build. So that's my, oh, I love it that you have the same, okay. So that's my basic framework. I thought it would be a kind of a good framework that you could apply to a lot of different areas of graph, interpret the graph, do some computations about the graph, and then make some conclusions.